Today I'm going to talk about the sorting algorithms. First, we will start with what is sorting. Then I'm going to introduce you iterative sorting algorithms, bubble sort, selection sort, and insertion sort. Let's start. What is sorting? So sorting is a process of arranging a list of items in a particular order. Let's give it an example. So we have a list which contains the test scores of the students, and we want to learn the highest grade and lowest grade. So how we can obtain this highest grade and lowest grade? So if you apply a sorting process to this list, which contains numeric data, which contains the exam scores of the students, you can easily obtain the highest grade and lowest grade. So you have a list of test scores, and if you apply the sorting algorithm, and if you apply it in ascending order, so you have a sorted array in ascending order, and you want to learn the highest grade and the lowest grade is at the beginning of the list, and the highest grade is at the end of the list. So you can apply the sorting process again into another kind of list, a list which contains the names and surname information of the students, and you want to sort the names in alphabetical order. So again, we're applying a sorting operation. In this case, you have different values. They are not integer or numeric values, but in this case, we have strings, we have characters. Again, you can apply sorting process to these kind of values. So also think in last lectures, we talked about the binary search problem. And we want to make a search, and we have a binary search technique. And as I told you that, what is the important condition for binary search? If you want to apply a binary search, the input list must be sorted. So this is a condition. You can apply the binary search algorithm to sorted arrays. So again, if you are making a searching operation, a sorted array, a sorted list is very useful in your searching operation. Okay, so let's look at the bubble sort algorithm then. It is a simple algorithm, simple sorting algorithm, but we cannot say that, okay, this is the most efficient algorithm, okay? But it is the simplest sorting algorithms. Let's look at the idea behind it. So it puts a list into increasing order by successively comparing adjacent elements. So you have a list which contains a lot of members. You are making a comparison between adjacent members, adjacent elements. So you are checking their values, and if they are not in correct order, so you are going to apply a swapping procedure. Let's look at the example. Here we have a figure. This figure shows the steps of bubble sort algorithm. So assume that we have a list which contains the values 3, 2, 4, 1, and 5. So this list contains 5 elements, 5 values, and we want to apply bubble sort algorithm. So if you look at the figure, you see that we obtain the list in increasing order after finishing the 4 passes. Okay, in the first pass, look at in the first pass, we are comparing the adjacent elements. So the adjacent elements 3 and 2. The first element with the second element. So the value of the first element is 3 and the value of the second element is 2. So you are comparing 3 with 2. And if the value of the first one is greater than the second one, you're going to apply a swapping operation. So here, the first one has a larger value than the second one. So you are going to apply the swapping operation, and you are going to change their order. Because if the value of the first one is greater than the second one, it means that they are not in the correct order. They are in wrong order, so change their order. And so here we found that they are not correct order, and we change their order. In the second case, you see that we change their order, and the list now has new form. In this new form, the order starts with 2 and continues with the 3, 4, 1, and 5. So we continue to make the comparison. In this case, we are picking the second one and picking the third element. Taking the second and third element and making the comparison. So take the 3 and 4 and make the comparison. So the value of the first one is less than the value of the second one. So 3 is smaller than 4. It means that they are in correct order. So nothing, we are doing nothing, okay? They are in the correct position. So we continue to make the comparison. In this case, we are going to compare 4 with 1. So the value of 4 is larger than the value of 1. So it is greater than 1. So they are not in correct order. And we are applying a swapping operation again here. And after applying the swapping operation, the list has new form. The new form contains the values 2, 3, 1, 4, and 5. So after making this comparison, the last comparison is between 4 and 5. So if you compare these pairs, the value of 4 is less than the value of 5. So they are in correct order. These pairs are in correct order, so we are doing nothing. And then after finishing first pass, we obtain a list. Okay, we change the places of some elements, but after finishing the first pass, the array is not in increasing order. If you look at only the last element, 5 is in correct order, but the rest, 2, 3, 1, and 4, okay, we need to check them again. So after finishing first pass, we know that the last element, which is 5, it is in correct order. So if you come to second pass, you continue to make these passes in the second pass. Now we show these 5 with blue color and in a rectangle. It means that numbers in this color shows that we guaranteed that it is in correct order. So 5 is correct order, so no need to check it again and again. So in the second pass, while we are doing the comparison, so we are not making a comparison with 5. Let's start the second pass. In the second pass, again, we start to make the comparison with first and second values. So the first element has value 2 and the second element has value 3. Compare 2 with 3. So 2 is less than 3, which means that they are in correct order. So 2 and 3 is in correct order. Continue to make comparison between 3 and 1. So if you compare 3 with 1, you saw that 1, the value of 1 is smaller than 3. So they are not in correct order. Swap 2 elements. So we are going to swap these 2 elements. After applying the swapping operation, we will obtain the new list which have this element, which has these elements 2, 1, 3, and 4. And compare again 3 and 4 here. So the value of 3 and 4, the first one, 3, the value of the first one is smaller than the value of the second one. So 3 and 4 in correct order. So no swapping operation needed. Then after finishing the second pass, we reach the new list, which contains the elements in the following order: 2, 1, 3, 4, and 5. And after finishing the second pass, now we guarantee that the last 2 elements, 4 and 5, they are in correct order. Okay, so if you look at the third pass, in third pass, we put 4 and 5 in a rectangle box and we colored them with blue color to mention that they are in correct order. So please make the comparison with the other elements. And we start the third pass. Again, we compare the first 2 elements, adjacent elements in the list. So if you compare the adjacent elements 2 and 1, you see that the second element has a smaller value than the first one. So you are going to apply a swapping operation here. You are going to change their order. So the new form becomes 1, 2, 3, 4, and 5. Again, you continue with 2 and 3. So if you compare 2 and 3, you can see that they are in correct order. So no swapping operation needed. And after finishing the third pass, okay, we have the list. 1, 2, which contains the elements 1, 2, 3, 4, and 5. So one more time, we are going to check that all the elements are in correct order or not. So we have 5 elements in this list, and we are going to apply 4 passes to this list. And if you look at the fourth pass, in fourth pass, okay, we know that 3, 4, and 5, they are in correct position, they are in correct order. So just check the first 2 elements. So if you compare the first 2 elements of the list, 1 and 2, again, you can see that this pair in correct order, the elements in correct order. So we finish this sorting operation. Then we apply the bubble sort algorithm. We compare each pair of adjacent elements in the list, and if you, after making the comparison, if there is a problem, if we saw that they are not in correct order, we swap these 2 elements and we obtain new form of the list. And let's look at the bubble sort algorithm's pseudocode here. In the pseudocode, you can see that we have nested for loop. In the nested for loop, the first for loop starts from 1 and goes till n-1. So this is the outer for loop. And if you look at the inner for loop, j starts from 1, goes till n-i. Be careful, n-i, because in the passes we know that after finishing the first pass, we know that 5 is in correct position. After finishing the second pass, we know that 4 and 5 correct position. After finishing the third pass, we know that 3, 4, and 5 in correct position. So here, in the inner loop, j starts from 1, goes till n-i. And in the if statement here, we are comparing the values of the adjacent pairs. So if you make the comparison of adjacent pairs, if the value of the first element is greater than the value of the second element, then you are going to apply a swapping operation. Here in the bubble sort algorithm, in the bottom part, I also put Java language implementation of bubble sort algorithm. So here we have an integer array input. So again, we have nested for loops. The outer loop starts from 0 and goes till list.length. And in the inner loop, we have another index j starts from 0 and goes till list.length -1 -i. Be careful, -1 -i. And in the body part, if you check the body part, you see that we have an if statement, and in the if statement we are comparing the values of the adjacent elements. So according to values, if there is a problem in the order, we are going to apply a swapping operation. And be careful, when we are applying swapping operation, here we have a temp variable. Be careful, we have a new variable. We are storing the first element's value into temporary while we are doing the swapping operation. And after finishing bubble sort algorithm, the next one is the selection sort algorithm. So in selection sort, again finds the smallest number. Again sorts the array in increasing order, and let's look at the idea. So here in selection sort, finds the smallest number in the list. So here we have a list. In this list contains the values 2, 9, 5, 4, 8, 1, and 6. So we have this list which contains integer values. So here in the idea selection sort, find the smallest value in the list. So here the smallest value is 1, and swap it with the first element. So who is the first element? 2. So swap it with 2. And after swapping operation completed, now 1 is in correct position. Then look at the remaining list. Remaining list contains 9, 5, 4, 8, 2, and 6. Okay, so then finds the smallest number remaining. Okay, so look at this remaining list. In the remaining list, find the smallest value. So smallest value is 2. Take the 2 and swap it with the second element. So who is the second element? 9 is the second element. Okay, find the smallest element and swap it with 9. And now number 2 is in correct position, so no longer needs to be considered. So we then continue with the list 5, 4, 8, 9, and 6. Again, find the smallest one. Who is the smallest? 4 is the smallest. And swap it with 5, the third value. Okay, third element. The third element. Now, after swapping these, now number 4 is correct position. Be careful. 1, 2, and 4. We show these 3 numbers with blue colors. So then the remaining ones with black color, 5, 8, 9, and 6. So here in the remaining list, again, try to find the smallest element. So 5 is the smallest, and we want to put these 5 in the fourth position, fourth element. So it is in correct position. So no swap is necessary for 5. Then we know that 1, 2, 4, and 5 already sorted in correct position. Now we have 8, 9, and 6 remaining list. So here again, try to find the minimum element. 6 is the minimum element. So swap 6 with the 8. Okay. So after applying this swapping operation, the new list has the form 1, 2, 4, 5, 6. Then we have 2 elements remaining, 9 and 8. So again, find the smallest one. 8 is smaller than 9. So one more time, you apply the swapping operation. So after applying this swapping operation, the number 8 is now in the correct position and no longer needs to be considered. So since there is no only one element here, we have just one element, 9. So there is only one element remaining in the list. It means that the sort is completed by applying the selection sort algorithm. So we sorted the array in increasing order. Here, be careful. In the bubble sort, we make the comparison between the adjacent elements. In selection sort, what are we doing? We are trying to find the minimum element of the list. At the beginning, okay, you search for the minimum element of the list. After finding the minimum element, you replace it with the first element in the list. Then you continue to this procedure, and after applying it to all the numbers, you obtain a sorted list. Okay, so this is the selection sort. Let's look at the selection sort algorithms, pseudocode, and Java language implementation. Here we have again nested loop. In the outer loop, for loop starts from 1, goes till n-1, and the inner loop starts from j. J starts from I plus 1. Okay, be careful. The starting point of the j, it starts from I plus 1. And goes till to n. Okay, you are going to find the minimum element, smallest element. So here we have an if statement here. In this if statement, we are trying to find the minimum element. Okay, so after finishing this inner for loop, we have a check condition. Again, we have an if statement. In this if statement, we are comparing the minimum index with index I. If these two index values are different from each other, we are applying a swapping operation. Let's look at the Java language implementation. In Java language implementation, okay, again, we have nested for loops. In the outer for loop, I starts from 0 because we are working with arrays. So array indexes starts from 0 and it goes till list length -1. And then here we are taking the element and we assign it as current minimum element and also store that index as current minimum index. And in the inner loop, again, I'm repeating, j starts from I plus 1. So you are going to make comparison and j starts from I plus 1, right hand side. You are making the comparison right part of the element, okay, right part of the array, okay. So here when you are making the comparison, you compare the current minimum element with list j. If you find a value which is you find a value in the list which has smaller value than the current minimum, you are going to update the current minimum value and current minimum index value. Okay, so here we have this if statement to find the minimum value, the smallest element. Okay, so after finishing the inner loop, here we have an if statement. You are comparing the current minimum index and the index I. So if they are different from each other, you are going to apply a swapping operation. For example, here in the example, so we have 9, and we start to make comparison with the rest of the values, and we find that the smallest value is 2, and now we know that 2 is the smallest one, and the position I is equal to 1, but the current minimum index is different than 1, so we need a swapping operation. You are going to swap 2 with 9. Okay, so here this if statement, we are, if necessary, we are doing swapping operation. We are checking that condition with this if statement. And the last one, insertion sort algorithm. So again, it's a simple algorithm. We have a list which contains n elements, and be careful here. In insertion sort algorithm, the sort begins with the second element. Okay, the sort begins with the second element. If you see this figure, so we have a list which contains the values 2, 9, 5, 4, 8, 1, and 6. So we are starting from the second element, okay, 9, not 2. So what are you doing? You are comparing 2 with 9. And if the value of the second one, so this is the second element and the 2 is the first element, you are comparing the first element with the second element. If the value of the second element is less than the first element, then you are inserting this second element before the first element. But if the value of the second element is larger than the first element, then you are going to insert this second element after the first element. Okay, so after making this comparison, now first 2 elements in the correct order. Let's look at 2 and 9. So we start with second element 9, and we will compare it with 2. Compare 2 with 9. So 9, the value, the second element has larger value than the first one. So you are going to insert it after 2. So 2, 9 now is in correct order. Then we have a new value which is 5, and we take this third element, and we are going to compare this third element with first element and second element. So look at 5. 5 is smaller than the 9, but it is larger than 2. So the order becomes 2, 5, 9. Okay, so every time you are picking a new value and you are going to compare it with the left part of the values. Okay, so here the next one, for example, the next element, the next value is 4. So compare it with 9, 5, and 2, and find the correct place of value 4. So 4 is smaller than 9, smaller than 5, but it is greater than 2. So the order becomes 2, 4, 5, and 9. The next element 8. So 8 is smaller than 9, but it is greater than 2, 4, and 5. So then you put 8 before 9, but after 2, 4, and 5. Let's look at the new value 1. So new value 1. 1 is less than 9, 1 is less than 8, 1 is less than 5, less than 4, less than 2. Then it becomes the first element of the array. And let's look at the 6. Okay, this is the last element. So compare 6 with all the other members of the list. So 6 is smaller than 9, smaller than 8, but it is greater than 5 and also 4, 2, and 1. So the new form of the list becomes 1, 2, 4, 5, 6, 8, and 9. Let's look at the algorithm. So this is the insertion sort implementation, again Java language implementation. We have nested for again. The outer loop starts from 1. Be careful again in insertion sort. One more time. Let me, okay, previous one. Okay, just a second, please. So insertion sort. the most efficient one, we told you that, okay, it starts with the second element. Okay, be careful. The sorting, insertion sort begins with the second element. So in second element, because of it, I starts from 1, not I starts from 0. So you are taking the current element, you are storing the current element, and then in the inner loop, here you are making you start with k starts with I minus 1. So for example, I is equal to 3. If I is equal to 3, so k starts from 2 and goes till k is greater than or equal to 0. And at the same time, look at the loop continuation condition. We have an extra condition here. If the value of list k is greater than current element, you can run this loop. But if k is equal, if it is less than 0 or list k is less than current element, then you are going to terminate this loop. Okay, so here, for example, we have 5. Let's talk about 2, 9, and 5. We have third element 5, and we want to find the correct position of element 5. So the index of 5 is equal to 2. Okay, so I is equal to 2. Then k becomes, k starts from 2 minus 1. So k starts from 1, goes till it is equal to 0. But again, don't forget, we have another loop continuation condition here. So list k, list 1, the value is equal to 9. So compare 9 with the current element. The current element is equal to 5. Compare 9 with 5. So 9 is greater than 5. And the index also, k value is greater than 0. So enter the loop and take this value, which is 9, and put it in position 2. So the position of 9 becomes here in the new form, okay? So at the beginning, the position was 2, second position, but now it is in third position. Okay, again, one more time, you turn to loop, decrease the k value by 1. Now the new k value is equal to 0. Okay, look at the loop continuation condition. K is equal to 0, and make the comparison. What is the value of list 0? The value of list 0 is equal to 2, and current element is equal to 5. So 2 is less than 5, which means that this turns false. This comparison operation turns false. Then this loop terminates. After terminating, finishing this loop, we are coming this line. In this line, what is the value of current element? The current element is equal to 5, and you are going to put 5 to position 1. So the last value of k is equal to 0. So 0 plus 1, list 1. You're going to put 5 in list 1 position. Then the array has the form 2, 5, 9. Okay, so if you run this algorithm, you're going to obtain the sorted version of this list. Okay, so today I introduced to you sorting algorithms, starting from the bubble sort algorithm, then we continue with the selection sort. Finally, I told you insertion sort algorithm. And thank you for listening to the lecture. Have a nice day.